Okay, this is number 25 from section 4.2, some of our homework problems. And again, we're trying to find the relative extrema and then the intervals in which the function is increasing or decreasing. So number 25, h of x is equal to negative x all over x squared plus 4. So we do have a quotient rule here we'll have to apply to take the derivative. So low d high, low is x squared plus 4 times the derivative of the top, which is negative 1, less the top, high d low, the derivative at negative x times the derivative of the bottom, which is 2x, denominator squared below. And this is going to be negative x squared negative 4, and the negative times the negative is positive 2x squared, all over x squared plus 4 squared. So this is all we have. So h prime of x equals, and then we just simplify this. 2x squared minus x squared is just 1x squared minus 4, all over the denominator there, and we can factor that x plus 2 times x minus 2 all over the denominator x squared plus 4 squared. And again, we're going to check for critical numbers. So where is the derivative equal to 0 and where is it undefined? Well, it's going to be equal to 0 on the top is 0. So that's going to be when x is either equal to positive 2 or negative 2. So that was nice. Okay, where is it going to be undefined? What's going to be undefined whenever the bottom is 0? Well, the bottom will never be 0 because x squared is always positive, and the smallest it could be would be 0. So I will always have at least 4 on the bottom. So it's not going to be undefined. So these are my critical numbers, positive and negative 2, positive 2. And I'll check my derivative. Now, since the bottom is always positive, I just have to look at the top. So I just tried negative 3. Negative 3 squared is 9, minus 4 is positive, so I positive. And then I put 0 in here. 0, negative 4 is negative 4, it's negative. Then I put 3 in here, h prime of 3. 9 again is minus 4 is positive, so my derivative is positive. So my function is increasing, decreasing, increasing, because the derivative is positive, negative, positive on these intervals. So I want to find the values that go with them so I can have my points, my relative maximum and relative minimums. Looks like I have a relative maximum here and a relative minimum there. So we'll go over here to our original function. This is h of x equals negative 8x. Okay, all over x squared plus 2. So we put negative 2 in there, so there's a negative in the function. So negative 2. The secant is always positive, but that's 2 squared plus 4. So that's 4 plus 4 is 8, and that's a positive 2, so that's 1/4. And then h of 2, there's a negative again in the formula. That should be over there. So that should be negative here in this formula. Okay. So h of 2 is negative 2 all over, again, 8. So that's negative 1/4. So these are the values that go. So I've got negative 2, 1/4, and I got 2, negative 1/4. So this was the relative maximum at negative 2, relative maximum at negative 2, 1/4. Why? Because h prime, that's the derivative, changes from positive to negative there. And at positive 2, negative 1/4, there's a relative minimum. Why? Because h prime changes from negative to positive there. Okay. And then since the derivative is negative, since the derivative is greater than 0, pardon me, this is the B part of these questions. All right. Since the derivative is positive from negative infinity to negative 2 and from 2 to infinity on these intervals, since it's positive, we say that the function is increasing. The function is increasing. The derivative is positive, so the function is increasing on negative infinity to negative 2 and 2 to infinity. And those will be closed at the numbers. Okay. Now, since h prime is negative on negative 2 to the open interval, okay, on the open interval, we say that h prime is decreasing, the function is decreasing. Since the derivative is negative, the function is decreasing on the closed interval, negative 2 to 2. Okay? So take a look at that, and I hope that helps.